Hi, welcome to Girls Who Maths. I'm Libby. We're following on from a previous video for the AQA 2019 higher paper, and paper 2 this is. So we've done questions 1 to 8, we're now going to do questions 9 to 15. So let's get started. The question says, in sport, injury time is added time played at the end of a match. The table shows the injury time in minutes, and it's played in 380 matches, and you've got given a table with that information. And it wants us to circle the 2 words that describe the data. Now we have the words that are continuous, discrete, grouped and ungrouped. Now looking at our data, injury time could be anything from 1 minute, 1 minute 30, 1 minute 48. It could be any number infinitely within those data series. It's not discrete in terms of you can't count it, so it's not one person, you can't have half a person, it's very discrete numbers, whereas time is measured, so therefore it's pretty continuous between the ranges. The first word is continuous for that fact that it's the measured number. Now the second 2 words are grouped and ungrouped. So as you can see here, we have grouped our data in terms of between these ranges of time. There is a grouping system being used here, and therefore the data must be grouped. Moving on to the next part of this question for 9b, it says which of these class intervals contains the median? You must show your working. Okay, so the median is the middle number in the data set. So if we have a data set of how many, we have 380 matches, so our complete data set is 380 bits of information. So we want the middle number of 380. So we do that divided by 2, and that equals 190. So the middle number in this data set is the 190th reading, okay? So now we need to see, well, which interval would that fall into? Well, if we do it based on the frequency, it's not going to fall in the first band because that's only got 59 in. We want the 190th. So let's look at the next one. Well, 158 plus 59 equals 217, which is bigger than 190, which means that the 190th point must fall within that second band. Therefore, the class interval that contains the median must be t is less than 2, but less than 4, or greater than 2. The final part of question 9 says, what percentage of the matches have more than 6 minutes of injury time? So let's look at our frequency table again. Okay, well, how many had more than 6 minutes? Let's start there. Well, this band here is more than 6, so 45 definitely had more than 6. And in addition to that, the last band, which is between 8 and 10 minutes, also definitely had more than 6. So if we add those 2 together, we get 57. So 57 matches fall into the band that we're looking for. And now we just need to work out what that is a percentage. So we need that as a percentage of the total amount of matches. And to do that, we just do 57 divided by the total amount, which is 380. And that gives us 0.15. But remember, we want it as a percentage, so we times that number by 100 to get it, instead of being as a decimal, we want a percentage, which equals 15%. So that means that 15% of the matches had more than 6 minutes of injury time. Question 10 now. It says that x is an integer and it gives us 2 inequalities relating to x. And it wants us to work out the possible values of x. So the easiest way to do this is to start with the integer based on just the number itself, just x, and work out what the options could be. So looking at the integer, it has to be greater than -4 but does not equal -4, therefore it has to be -3 and above, -2, -1, 0, 1, and the upper limit is 2, but it does include 2, so it could be 2. Now, what we can do is we can just plug these values into here and check that if it's greater or equal to 2 or less than 9. So, -3 plus 3, 0, which means it's not -3, -3, in this case would equal 0, and therefore doesn't fit in that bounds. -2 plus 3, again, it's 1. Not going to be that one. -1 plus 3 is 2. And remember, this means it has to be greater than or be 2, so that one's fine. 0 plus 3, 3. Happy with that one. 1 plus 3 is 4. We're happy with that one. And 2 plus 3 is 5. That'd be that one. Therefore, the possible values for x are -1, 0, 1 and 2. Question 11 says that Joe and Kyle share an amount of money in the ratio 7 to n. So that means that Joe gets 7 portions, Kyle gets n portions, and Joe gets 35% of the money. Work out the value of n. Okay, well we know that Joe gets 7 portions of the total, and the total amount of portions available is the total of the ratio, 7 plus n. So we know that 7 of the total goes to Joe, and that equals 35%. Now I've written it here as decimal, but obviously you know that 35% just equals 0.35. So now we've got an equation form, so all we need to do is solve the equation for the value of n. So we can do that by moving the 7n across. We can divide by the 0.35. That gives us 7 plus n. So we do 7 divided by 0.35. That equals 20. 7 plus n. Move that 7 across. So we do 20 minus 7, 13. So therefore, Joe gets 7 and Kyle gets 13. So n is 13. Question 12 now. It says that a bias coin is thrown 250 times. The relative frequency of heads is worked out after every 50 throws, and it gives us that information. And it wants us to circle the best estimate for the probability of heads. This is a nice 1 marker. It doesn't need us to work anything out. It just needs to check our understanding of probability. So with questions like this, the more throws, the more rolls, the more data you collect for a certain probability, the more accurate your prediction is. So therefore, we go right to the end where we have the most information, which is after 250 throws, and we just take the relative frequency, so the probability of it being a heads at that point. Here it's 0.3. The answer is 0.3 because after the most amount of rolls, we have the most data, meaning that our estimate of the relative, our calculation of the relative frequency is most accurate, therefore gives the best estimate for the probability. Question 13 now, and it says the amount spent on clothes by 40 boys and 40 girls in 1 month were recorded. The table shows the information about the amounts spent by the boys. You've got this table with some blanks in. And the question says the mean for the girls was £35. Estimate the mean for the girls as a percentage of the mean for the boys. So firstly, we need to work out what the mean for the boys is. And to do that, we need to complete the table. So you can see we have a midpoints category. So it's hinting to us what we need to start with. So let's start with the midpoint of each of these categories. So we just take right in the middle. Between 0 and 20, 10, 20 and 40 is 30, 40 and 60, 50, and 60 and 80 is 70. And then we want to fill in this category, which should be the totals category. And to do that, what we need to do is we need to times the midpoint by the number of boys to get the average cost spent per group. So we do 10 times 22, which is £220, that is. 30 times 9, 270. 50 times 6, 300. And 70 times 3, 210. 210, and we want the total for those, so we add them all up. So 220 plus 270 plus 300 plus 210 is £1,000. So the total for that is £1,000. And we know that there was 40 boys, so we know that the total spent by the boys was £1,000, but we want to know what the average was, the mean. So we do 1,000 divided by 40 to find out per person what the mean was. 1,000 divided by 40 is 25. So the average per boy, or the mean, was 25. We have the mean for the girls at 35, and the final part of the question wants us to do the percentage for the girls as a percentage for the boys. So that means that we want to know the girls' number as a percentage of the total boys. So we put the girls' number on the top, which is 35, the boys on the bottom, which is 25. We work that out on our calculator as 1.4. But remember, it wants the answer as a percentage, so we times that number by 100, and that gives us 140%. And if you're a bit unsure whether you've done that the right way around, think about it as the girl's number is bigger than the boy's, so it must be more than 100% because it's a bigger number. Therefore, the answer is 140. Question 14, okay, this is a two-parter. And the question says that Ali and Mel are making 3-digit codes, but digit 0 is not used. Ali only uses the odd digits and Mel only uses the even. Ali can make X more codes than Mel. Assume the digits cannot be repeated. Work out the values of X. Let's start with looking at what digits they can use. So Ali can only use odd digits, which means he can only use 1, 3, 5, 7 and 9. Mel only uses even, so if we're excluding 0, evens are 2, 4, 6 and 8. So Ali's got the choice of 5 digits, Mel's got the choice of 4 digits. And the digits can't be repeated. So let's work out how many codes Ali can make. Well, he's got 5 options for his start. So he can start his number with any of those 5. So let's say, for example, we pick the 1. The number will start with a 1. That then leaves us 4 digits left for the next number because they can't be repeated. So we times it by 4 because that gives us 4 options. Let's say we pick 3 for that next number. And we times it because we can do any combination of those, which means that we have to do a multiplication. Now that leaves us with 3 digits for the last number, so we pick 5. We've got 3 digits left. So he's got 5 options for the first digit, that becomes then 4 for the second, which becomes then 3 for the third. So we times those and that gives us 60. Ali has got 60 options for his code. Mel, on the other hand, it's a similar process, but she has less numbers to choose from. She only starts with 4, which then goes down to 3 for the second number and 2 for the third number. So when we multiply that, we get 24. So Mel only has the option to make 24 codes. Now we want to know how many more Ali can make than Mel. And to do that, it's a simple subtraction of the two numbers. So we want to know the difference between the two. So we want to know 60 minus 24, which is 36. Therefore, X is 36. It means Ali can make 36 more codes than Mel can. The extension to 14, so 14b now says that in fact digits can be repeated. What does that tell us about the actual value of X? Click one box and we've got 3 options. Well, if the values can be repeated, instead of the calculation we did in part 1, it would now be, which was 5 times 4 times 3, it would now just be 5 times 5 times 5 because each digit he puts in his 3-digit code can be a choice of any of them, so it can be a choice of 5. So the amount that Ali can now use is 5 times 5 times 5, 5 cubed, 125. And Mel, remember she only has 4 numbers, so she can only do 4 times 4 times 4, 4 cubed, 64. And therefore we can just work out what the actual value for X is, which is 125 minus 64, which is 61. So the actual value of X is 61. In part A, we worked out the value of X in that case was 36. Therefore, the actual value of X is bigger than what we worked out in part A. So the answer for this one is the first box, that it is bigger than my answer to part A. Question 15 now, and it says here is the line L and the graph of y equals x minus 1. The scales of the axes are not shown. And it wants us to work out the equation of line L. Okay, so yours will obviously be a bit more detailed than this. You'll have more lines and crosses and that sort of thing. But what we need to do first is we can work out the scales. Because they're not shown, there's no way to figure out this equation as line. So we need to work out kind of what each marker means. And we know the information for y equals x minus 1, so we can use that to work out what the scales must be. Okay, now we know the equation for a line is that, where C is the y-intercept. So looking at this equation, y equals x minus 1, the C in this case is minus 1, which means the y-intercept must be minus 1. So this point here must be minus 1. Now on yours, you can see this is the first bold line below the x-axis. So each bold line, as you'd like to call it, is a whole 1. So minus 1 down, that means that one's 1, 2, 3. Now let's look at a cross. We don't know it might not be the same. So we know that it crosses the x-axis at this point, and that means that y must be 0 at this point. So we have 0 equals x minus 1. At that point, when y is 0, we move the 1 across, we get x equals 1 at this point here. So that means that one is 1. So every second bold line going down is a 1. So therefore the next one is there, which is where the next line crosses the x-axis. So let's look at the equation of this line now. Okay, well we need the gradient, we need m, gradient. And we need the intercept. So we can work out the gradient. We can do this 2 ways. I'll show you one way, but there's another way to do it, which I'll explain in a minute. The gradient is the change in y over the change in x. Remember, the triangle is just changing. So this line that we're looking at, this one going down here, goes from 3 down to 0, because we can know that. They're the points we know. We know it's at 0, 3 and 2, 0. So the change is 3. But it's going down, it's coming this way down, so it's a minus. And the change in x, well, it goes from 0, 3 to 2, 0. So it's 2, so that's the gradient, it's minus 1.5. So let's look now. The information we have for our line is this, and then all we need to see, which is the y-intercept, and we know that now we've put our scales on, is 3. So y equals minus 1.5x plus 3. The other option for working out the gradient would be to determine your y-intercept, so you'd have y equals mx plus c, and then you can set that line equal to this line, and because they cross at that point, and that will be able then to derive m from that. We've done it this way, and our answer is y equals minus 1.5x plus 3. We've just done questions 9 through to 15, so tomorrow we'll be releasing the video with questions 16 to 20.